Thank you for joining us today. My name is Sharth Chander. I'm part of the Java platform group here at Oracle. And for the next 45 minutes, I'm going to be the moderator for this panel session. It's Ask the Architect, Java Architects. And we actually also have two engineers with us too, who are very critical to driving Java forward for us. Now, many of you are familiar with panel sessions, but this is really your chance to ask questions about the Java language and the platform. So make sure to submit your questions in the Q&A field, and I'll be checking that throughout the course of today's panel. So for this next 45 minutes, you'll have a chance to hear from all of our panelists today. And I'm very thankful to welcome Mark Reinhold, Chief Architect, Brian Goetz, Chief Language Architect, Mikael Vidstedt, Senior Director of Software Development, and Ron Pressler, Consulting Member of Technical Staff. Gentlemen, thank you for joining today's panel. It's great to have you here. It's pretty memorable in that last year, we celebrated 25 years of Java. And if I'm looking at all the questions coming in, one that seems obvious to ask all of you right now is, what's kept Java vibrant and popular for over a quarter of a century? I thought, Mark, maybe we can start with you.
Well, I think there are many things that have helped keep it vibrant and popular for so long. Um, I think probably the main one is that we've always been guided by a clear set of values, and we've taken the notion of stewardship very seriously, perhaps more seriously than many other platforms. Um, to put that another way, we don't just develop the platform. We don't just add stuff to it. We don't just look around and say, "Ooh, what's cool this year? Let's add that because language X or language Y has it." We actually take a deep amount of care when we add things to the platform, when we make changes, when we occasionally, rarely remove things, to make sure that it makes sense for the ecosystem as a whole, for the long term. So this notion of stewardship is extremely important. And in pursuit of our main values, the fact that the Java language and platform emphasize readable code. Readability is a key value. The other key value I would say is compatibility. We take compatibility seriously, even though we do occasionally remove things, as we have recently. There are many dusty jar files out there created on Java 1.0, Java 1.2, Java 1.4 that still work just fine today, and that's not something you can say about other platforms. I think another big factor in the longevity, has been the ecosystem, the community as a whole. Just we've been able to maintain an atmosphere of support and collegiality. We have all the user groups and conferences around the world focused on Java and related technologies, and those have also been a huge boost over the years.
Sounds like thoughtful evolution, thoughtful pruning, but also thoughtful participation. So
Yeah.
thank you for that. Ron, from your perspective, what's kept Java vibrant from your lens?
Um, well, I think that over the years, the reasons for Java's popularity might have changed. These days, I think it is mostly recognized as a serious platform for serious software. It's dependable, and it offers an unparalleled combination of performance, productivity, and observability, by which I mean monitoring and profiling. But in a slight digression, what drew me personally to come to work on the Java platform is that the technology at the core of OpenJDK, the optimizing JIT compilers, the garbage collectors, the low overhead in production profiling system, is just state of the art. So I was mostly drawn because of how cool the technology is.
So that 25 years of rich history has produced a lot of tools and features that just makes it that much easier to approach from a developer's productivity standpoint. That's true. Brian, as a language architect, you must have some interesting perspective on this.
Yeah, I could talk about this for a long time, but just very quickly to add to the points that Mark and Ron made, I think the stewardship, and the values, that we bring to evolving the platform are also augmented with what I think is a somewhat unusual blend of theory and practice, which is to say that at the surface where, the platform meets the programming model, which is what most developers see every day. We have focused on evolving the platform so it stays relevant to the problems people want to solve. But at the same time, down in the engine room, the specification and implementation of the VM, the JIT, the garbage collector, the language specification, this is something that we take an immense amount of care with evolving. And as a result, we are able to continue to evolve the specification and implementation 25 years later. So when Ron talked about what an amazing implementation we have at the core of OpenJDK after 25 years of development, you could imagine an alternate universe after 25 years of development where we've been nailing bags on the side for 25 years and you can't fix anything without breaking something else. And what we have right now is the very opposite of that, because of the immense care that we've taken in the specification to make sure that every feature we add leaves the workshop cleaner than we found it, so the next feature we want to add can be added as well.
Yeah, that's a good point. A lot of times it's not about speed, because speed can do damage. It's about pace. Yeah. And pacing yourself typically helps you win the race, so to speak. Michael, I don't want to date you, but you worked on JRocket for many years. From your perspective, what's kept Java vibrant for so long?
Yeah, I've been through two JVMs throughout my career now, and I was actually counting it the other day. I'm still I think spent more time on JRocket than Hotspot, but it's getting close now. Any month that will change. Now, no, I think I want to echo what people said here. I think the nice part about the Java platform is that we have this really stable interface. The surface is very well defined, which means that, again, those old dust jar files from the 90s still mostly run, right? And it's complex. It can be challenging as an implementer to work with it, but it does give us a lot of freedom. A lot of the complexity has been pushed into the platform itself, so we can spend that time solving the problems so that users and developers don't really have to care about it as much. So the well-defined, stable interface leaves a lot of room for innovation beneath the surface. And obviously, like I'm really passionate about the JVM technology. It's a cool technology. There are a lot of different challenging areas, and we have a really healthy, cool community around this. A lot of people investing in Java, and all the way from companies to academia, and in the end, users helping us figure out what to do next. So lots of cool technology to work on here.
It's as if having a solid foundation is actually helpful before you build a house on top of it. So that's a very good point. We're getting a couple of questions that are kind of opinion oriented. The first one here is pretty interesting. It says, do you consider Java a functional programming language? If not, will it ever be one? Or will it never be one and just be good at being an object-oriented programming language with functional features? I'm kind of looking at you, Brian, for this one.
So I'm not going to answer this question. I'm gonna dodge a little bit because I don't think the labels of functional language versus object-oriented language are really all that helpful. I think they play into a false dichotomy that you have to approach a problem with a rigid methodology, and that's the only way you can solve that problem. And that's not a particularly helpful way to think about the tools we use in programming. The main challenge of programming is managing complexity, and complexity is everywhere, and it comes in many forms, and we need every tool we can get for managing complexity so that we can write clear, correct, maintainable programs. And the OO paradigm gives us one set of tools for managing complexity, largely having to do with how we structure our applications and define their boundaries. And the functional paradigm gives us another set of tools for managing complexity, largely about composing bits of functionality reliably from other bits of functionality. And both are useful and both are powerful, and we need both of these ways of thinking in order to solve the problems that we have to solve today. So Java will never be a pure functional language. I don't think it's really a pure OO language either, but I don't think either of those extremes matter. It's a language that has evolved over time and taken influence from multiple programming paradigms. And the result is what I call a broad spectrum language. Java is an effective language for writing low-level code. You can write, really fast, low-level data structures in it, and for writing high-level applications. And the fact that you have one programming model that spans that whole range is incredibly powerful.
Having kids now that are now getting into programming more often, my children are a lot smarter than I think any of us were at their age. And one comment that I've heard recently is, Dad, I'm not just making a turn on an oval loop. I'm going through S turns, I'm going on hairpins, I'm going on straightaways. And, the language I use needs to allow me to drive on a complex track. And I'm thinking, boy, these kids are so much smarter than I am at this point. But it's a great analogy. It's like, we're not just making left turns all the time. It's a very complex track that we have to navigate. And the language and the platform you use needs to navigate that type of track. Well, here's an interesting one. And I think this might be one of the ones where we could talk ad nauseum for hours. But this question says, language rankings are a slippery slope, but we see Java typically mixed in the top 3 year over year, whether 1, 2, or 3. What concerns do you have that Java is not ranked number 1 in some of those rankings? Mark, I'd love to hear your opinion on that.
It's not something that keeps me up at night, to be honest. I mean, okay, we all know the top 3 are. I mean, the Red Monk rankings just came out a few days ago. Java, JavaScript, Python in some order or another. Each one has its strengths. One of them has more weaknesses than the others, I would say. Too bad it has Java in the name, but there it is. I think what's more important is to focus on what each platform is good for, right? I mean, I write Python scripts sometimes. I admit it. Sometimes it's just the right tool for the job. But Java being, as Brian just said, a broad spectrum language and platform, often Java is actually the right tool for the job. Even these days, to write little scripts, now that we have the single file source code launching facility introduced a couple of releases ago, I now routinely write little scripts in Java. But anyway, to get back to the question, I think what's more interesting is to look at the adoption of each platform, and I think the adoption of Java, especially recent releases, is actually a bit better than many people think. Now, like language rankings, adoption is a difficult thing to measure. I see a lot of people out on the interwebs counting adoption by looking at download statistics, and frankly, I'd never believe download statistics because they're too easily distorted by things like automated build systems that just they download a JDK from somewhere every time you do a CI run, and so it allows the supplier of that JDK to claim, 5 million downloads in the last whatever period of time. Sorry, that's just not very persuasive. What I think is a little more believable, although still fraught with some amount of peril, are carefully done surveys of the developer ecosystem. And again, the surveys that we see done by third parties. Sometimes the questions are not as well formulated as one might like in a survey, but in general, and I was looking at these a couple of weeks ago, for some of the recently released surveys, we see that about 2/3 to 3/4 of respondents say they're using Java 8. About 1/4 to 1/3 say they're using 11, and up to 15% or so are saying they're using 12 or later, which these days will typically mean 15 or 16 early access. So I think that's good. A lot of people like to say, oh, well, the entire ecosystem is still stuck on 8 because it was so hard to upgrade past that. I think people in general are moving along. People have realized that moving past 8 is not as hard as many people have said. And so I think that's a good thing. Java will keep moving forward, and the ecosystem will keep moving along too.
Ron, looked like you had something that you wanted to include there as well.
Yeah, right. I think that Java's popularity in, say, 2000, 2005 was anomalous. And we're back in a world where no language is as popular as Java was then, and that includes Java itself. So I'm not worried about the #1 spot, but I do think that we need to stay in the top 3 or 4. And to do that, we have, of course, all the big projects to improve the runtime, the tooling, the language that people can learn about in the talks. But there is one more thing. I said before that Java is a serious platform for serious software, but it also needs to be easier to use for less serious software. So the single file Java launcher that Mark mentioned is one example, but we're mulling over some ideas and how to do more things in that spirit. Also, personally, I would like to see some more Java on the client, and in particular back in the browser, because client work is often a gateway for beginner programmers.
That's a good point. You know, Brian, as the language architect, you have to sort of keep abreast of what so many other languages are also doing. You know, how does that sort of reflect in terms of Java's stack against the other choices that are out there?
Yeah, well, it's a good reality check, right? And as Ron said, that, you know, we're coming into a time where there are a lot of different tools for solving problems, and some people decided, I like this tool, I like that tool for this kind of problem. And, you know, and there are a lot of credible choices out there, which means there's a lot of opportunity for us to look at how some problems might be solved differently and draw inspiration from that, right? And you know, we're not, you know, our culture is not one of lurching at whatever the latest hot thing is, which, you know, in some sense gives us a reputation of, oh, Java moves very slowly, but it also gives us what I call last mover advantage, which is there's a lot of bad ideas out there too. And I'm happy to let other languages do those experiments and discover that they're bad ideas, and then we don't have to worry about them. And, you know, so, I mean, I think that the rankings thing is, you know, it's a bit of a beauty contest, and, you know, everyone likes a winner, and everyone likes to say, you know, that you know, #1 is all that counts. And, you know, if I had $1 for every time someone said, oh, Java is dead, Java's the new COBOL, you know, I could have retired, right? Because people love to predict the demise of whoever was on top last week. And the reality is Java keeps chugging along because it's relevant. It stays relevant to, you know, the problems people want to solve. And, you know, we have, you know, in the last, you know, 2 decades, gone through a number of reinventions of the platform, which I kind of refer to as, you know, jacking up the house and pouring a new foundation while you're still having, you know, breakfast in the dining room. We did that with generics. We did that with lambdas. We did that with modules. Ron is about to do that with Loom again. And so, you know, we've been able to continue to teach this old dog new tricks so that it stays relevant to the problems people want to solve.
That's right. You know, it's amazing just how many times year over year over year we hear about the demise of Java and the headlines, the shocking headlines that Java is dead, only to hear that it's been resurrected the following year, followed by the year-end closing that it's died again. And so it's sort of like trying to keep up with that kind of crazy news cycle over and over again. Michael, what's your perspective on this?
Yeah, so I think what everybody else said. What I also will say is that some of the things may not be sort of as apparent to people, and that's all the time we've spent in modernizing everything around how we develop the Java platform itself, right? So the release model is probably the one that sort of sticks out the most. And you would not believe how much time that has saved us in terms of meetings on trying to pre-plan whatever was going to happen 3 years into the future, right? What we now do instead is focus on developing the features, and when they're ready, we integrate them. It's a much easier world to be in. I believe that is true for every developer and in the platform, and it's certainly true for me as a manager as well. So that is certainly one key thing, key way that we're sort of focusing more, I guess, on the important things, on moving the platform forward. And a lot of the stuff we do is very challenging. Modernizing a platform that is now more than a quarter century old is challenging. We need to do it in the right way. So being able to spend the time on that rather than, you know, the processes and all of that around it is certainly a very nice place to be. I'll also mention one of the things that sort of is very, very visible, and that's the move to Git and GitHub that we have done in the Scala project. That is also one of those very central tools. We were more or less, working with some, let's call it legacy infrastructure, and now we're, on the latest, greatest, cool thing. And I will also say that it could have been a very challenging thing, but it turned out that it has been extremely smooth. It just sort of worked from day one, and now we can start reaping the benefits on being on that new infrastructure and build other things on top of it. So we are significantly, I'm going to say, more efficient now than we were in the past. And that means, again, we can spend more time on innovation.
Having to spend so much of my day job just immersed in the community and keeping the ear to the ground, I will say that, if you as a developer are making your decisions purely on things like a Twitter poll as far as what language to use, be wary. So, there's risk fraught and things like that. So pick things that have proper methodology, well scoped out questions, because the totality of all of those surveys that are out there does give you some perspective, but relying solely on one can lead to dangerous decision making. Looks like we have a couple of questions in terms of planning. Here's a pretty good one. With shaping Java's future, how does the Java team prioritize the Java language features to implement? Mark, how do we do that?
Well, I guess the question itself suggests that our methodology is we have a big huge long list that we create with little judgment, and we just prioritize everything in it. I would cast the process insofar as there is one in a different way. I think what we're always looking for is what can we do in the core of the platform, with both the language, the VM, the libraries, that cannot be done outside of the platform. What can we do to help others build on top of it? As an example of that, as we all know, machine learning has been a very hot area for several years now. Many people have come around and suggested, oh well, the bfloat 16 floating point format, it's really important for TensorFlow. You should put that in Java, right? Or they've said, oh well, Swift is doing a TensorFlow API. The core Java platform should have a TensorFlow API. Things of this nature, and these are all well-meaning suggestions, but just doing those would in our view be the wrong thing, right? What is better for us to do? Anybody should be able to do a TensorFlow API, and in principle, anybody should be able to define a new, very efficient floating point type. Today that's not possible. So rather than add bfloat 16 to our little stable of unfortunate primitive types, we're working in Project Valhalla to make it possible for anyone to define their own effectively new primitive types. And yeah, maybe bfloat 16 is important enough that we'll actually define it in the platform, or maybe we won't. We'll decide that later. And that will allow people to do machine learning. Someone else outside of the Java platform group, even maybe outside of Oracle, can go write a really great TensorFlow binding so that you can use all that fancy hardware to do machine learning, and we can move on to the next thing. So I think the principle of doing in the platform what just absolutely cannot be done outside it is a good guiding one, and that's one thing that we constantly look for.
Yeah, and taking into account the fact that there's, I think, in some quotable numbers, over 12 million developers, this has to be done thoughtfully, because
yes, it has to be done thoughtfully. I sometimes say that compatibility is really important, and one axis of that is actually sort of intellectual compatibility, right? We don't want to break people's brains when we upgrade the platform. We really strive to make it look like every time something new comes in, that if you just came at the platform at that point, you would think, oh well, yeah, that kind of looks like it's been there from the beginning, even if it was only added a couple of years ago. And I think we've been reasonably successful at that.
Yeah, let alone breaking.
Brian wanted to add in.
Yeah, please go ahead, Brian.
Yeah, I mean, one of the things that we think about when we're designing language features is how can the language features enable people to write more powerful libraries, right? Because the not only do we want to focus on the things that only we can do, but library changes scale much much better than language changes. Language change takes a long time, it affects everybody, whereas if we can enable the ecosystem to solve the problem they want in libraries and to compete for who has the best TensorFlow or JSON parsing library or whatever, then everybody wins, right? Because we're making it easier for the ecosystem to solve its own problems.
And what some of that beauty of the last 25 years too is a lot of that hard work has been done by someone, right? So it's not just creating new libraries, but being able to allow those that have sort of like become sort of well established, be able to keep up and be utilized. So we don't all have to go and create something new out of the box. So that's a good point. I actually enjoyed this next question because coming from a tooling background, dare I say, back when I was on the NetBeans project, still love NetBeans, yay. This one's focused around developer productivity, and I'd love to get all of your perspective on this. But the question says, in your opinion, what are some of the classes, tools, utilities that Java programmers may not know about that they should be using today without hesitation? I thought, Michael, maybe we can start with you, because you and I have had some really thoughtful conversations about tooling.
Yes, right. There are a lot of tools that I think people may not know about that are super useful and that they definitely should try out. So let's see, where should I start? Well, so I guess one of the themes of this decade, I guess, for Java is about moving up to new releases and picking up new releases of functionality, right? And one of the some of the questions people have is like, what will break? Because obviously there's a lot of talk about all the stuff that we have removed and changed and how difficult it is. So there is a useful tool that we introduced a few releases ago called JDepper_scan. It's a great tool that you can find it in your Java home bin directory, and you point it at a class or a jar file, and it will help you figure out what you may be depending on that you may want to look into and potentially change. It's deprecated stuff and things like that. So you get very helpful warnings and pointers to code that you have that you may want to look at upgrading or changing in some way. What else should I pick? JLink, that was one of the other tools that I was traveling the world talking about a few years ago. So there is a great tool called JLink. If you download the JDK today, it's if I remember correctly now, it's somewhere in the order of 300 megabytes. And it turns out that half of that is actually the exact same data twice. Because what happens right now is that in the JDK we have modules and we package them in two different ways. One is as a linked version, pre-linked version, which is what you actually run. So if you run the Java command, that's the class data you'll use. But there's also, all the modules are also there as a separate concept which you can use JLink to create your own custom runtime. And so by doing that, you can tailor make it and to only include the data that you actually need for your application. So if you have a small one, maybe you only need a handful of the, what is it now, 50, 60, 70, 80 modules or something we have in the platform? Forget the exact number. Ballpark at least.
We keep removing them, so the number gets smaller. Lately. 60 something.
That's right. Yeah, so this is maybe especially useful maybe if you have container environments, you're building your Docker images and you want to keep them slim and small, right? The other thing to know about JLink is that it can tailor make also the runtime for your application and leverage sort of the fact that you're not using all this other functionality. And in sort of line with that, I also want to highlight, being the JVM guy I am, that there's class data sharing. It's functionality that is built into the JVM that allows you to sort of pre-compute some of the state ahead of time. So you do a training run of sorts, you store that data to disk, and then for subsequent runs, you can reuse that. We call it the CDS archive. And what that gives you is faster startup time and less memory footprint if you're running multiple processes on the same machine. So there are those kinds of things that you can look at doing to improve on the behavior or performance of your application. I do want to point out also that I said modules in JLink. Your application does not have to be module aware to use this. You can take your own old 90s Java application, and it will work just fine, right? So that's something to keep in mind. But obviously, if you want to use, if you are modularizing your application, it will work even better together with these tools. And then finally, if I may, because again, I'm a Java guy, right? JVM guy. I do need to mention JFR here as well. Ron touched on it earlier as well. We have a pretty superior story, I want to say, compared to many other runtimes around serviceability, monitoring, management, that sort of thing, and insights into what the runtime is up to. A few years ago, we open sourced JDK Flight Recorder, and what that effectively is a low-level sort of framework that collects events in a very low overhead way. This is meant for production, turned on in production, and it will collect all the data you can imagine and then some. So if you're wondering what the runtime is up to, what you should do to improve on the performance, or if you're running into some weird case where you're wondering, like, why is my network IO taking so long? JFR is likely going to be able to answer that question for you.
No, appreciate that,
Those are
Michael.
some of my favorites.
No, it's quite a list, and they all rise to the top. Ron, from your perspective, something that really stands out that developers should be using without hesitation.
I don't have much to add on top of what Michael said. Perhaps maybe just to re-emphasize that, again, jailing has become associated with modules, and in a way it is, but some people still think that your app needs to be modularized. It absolutely does not need to be. You can create a custom runtime for any application, and you should do that. On that, I'll just second JFR. JDepRescan, of course, with every version you must run it. It should become part of your continuous integration, and I don't have anything else to add.
No problem at all. Mark, anything on your end before we move to the next question?
Well, not to keep pounding the same drum over and over, but to follow up a little bit on the JLink comments, I just checked. JDK 16 has 67 modules in it, so 60s was about the right answer. Yes, it's absolutely right. If you can take a class path based application, run it with JLink. But another tool that's worth mentioning that only recently became available, we published this for the first time in 15, is the JPackage tool. So JLink is one big step. You can take your application, have a custom subset of the modules in the JDK, and bundle that up. The output of JLink is a thing that looks like the JDK. And that's not exactly what it is. That's not a very convenient form for final delivery. So JPackage sort of does the last mile. It will take that result and bundle it up into an operating system specific package. So you can build a macOS installer, a Linux RPM or Debian package. You can build a Windows MSI installer for your application. So it's a complete end-to-end story now. If you use both JLink and JPackage together, you can get a very nice result if you're trying to deliver packaged applications. And you can do that without having to rely upon your end users having a particular JDK installed, because you've got the subset of the JDK that you need right there in your app.
Brian, anything to add? Or
well, I just wanted to add a comment about JFR. JFR is really an amazing piece of technology that a lot of people don't know about, and it's a perfect example of the sort of thing that Mark talked about, which is the things that only we can do, right? So by instrumenting the JVM with both the infrastructure and the listeners to deliver events about what's going on inside of the JVM enables a whole ecosystem of monitoring tools that would be almost impossible to write from the outside. So it's not like we needed to build the monitoring console, we needed to build the plumbing to feed the monitoring console with data, and then we get out of the way and let the ecosystem figure out what's best.
Well, it seems like this next question is probably right up your alley, Brian. It says, should Java programmers give up setters and model their domain objects immutably, or with records only from here on out?
So at the risk of repeating myself, I think like the either or that's implicit in the question of there's one right way to model data in your program is a little bit misleading. Our colleague Alex Buckley likes to say, one of the surprising things about Java is it managed to get all the defaults wrong and still succeed, right? So in Java, the default for mutability is wrong. The default is mutable. The default for accessibility is wrong. The default for whether a class is extensible is wrong. And somehow we managed to survive these mistakes. But the Java Beans naming convention is a little bit of an unfortunate story in that it's a terrible convention for general purpose development. It was a fairly well-targeted convention for what it was designed for, which was visual components in a visual editor where you were dragging and dropping buttons and labels and things like that onto a canvas, and had property sheets that you could edit about, foreground color and fonts and what have you, which could be discovered reflectively. And so the Java Beans convention was a great way for building those components, which turns out to have not have been what people ended up using Java for. And yet somehow we continued with those conventions, even though they were such a poor match for most business domain objects. So I think the result of that is because of these conventions, mutability is greatly overused. And over the last 20, 25 years, people have started to realize that mutability is overrated, and that immutability is one of those tools we have for managing complexity so that we can focus our attention on the parts that actually have to be complex. And records is a language feature that kind of recognizes that. It makes it easier to model data as data, and it goes with a couple of other features, sealed types and pattern matching, which sort of together are moving us towards more of a data-oriented model of programming. I think as programs get smaller, used to be, we wrote these enormous monolithic programs, and we focused, over the last decade into factoring things down into smaller services, microservices, function as a service. More code is closer to the boundary, and therefore is going to have to deal with data that comes in not as a Java object, but some untyped string of XML or JSON or whatever. And we want to model it just as ordinary data, and the language is moving in a direction that makes it easier to do that. So, to the extent that tools like records are suitable for modeling the data in your program, that's a whole bunch of your complexity budget that you don't have to spend on dealing with mutability and coordination, and you can just focus on the parts of your program that actually are complex.
No, appreciate that. Thank you, Brian. We have about 10 minutes left, and there's still a lot of questions here in the queue. I think I have about enough time for 3 more, so I'm just going to pick through some of the ones that I think are really important to surface because of just the number of similar questions. And this one is keeping up on the Java releases. So there seems to be a lot of questions on this one. The one I'm going to pick is, what would you say to developers who are stuck on Java 8 or older versions to get them to just jump in and swim in the pool to enjoy current Java releases in terms of what they have to offer? Ron, I'm looking at you at this one. You always have a great story to tell here.
So I would say that they're probably losing a significant amount of money that using a modern JDK could save them. Improvements to footprint, like compact strings. Improvements to performance, like better compiler optimizations and faster startup. Improvements to both footprint and performance due to massive changes in the G1 garbage collector and the introduction of ZGC, a garbage collector that gives you pauses of 1 or 2 milliseconds, as well as improvements to JDK flight recorder that can help optimize application code. All of these translate to significantly less hardware that's required to serve the same workload. And on the cost side of things, updating post-8 is easier today than it was a couple of years ago. So in many, if not most cases, I think the savings in hardware or hosting would offset the migration costs very quickly.
All very good points. And beyond that, who wants to be below the security baseline to begin with? Do you really want to put your application or your enterprise at risk? It's shocking sometimes when you come across just how frequently that is the situation because they did not know. So you should know. another question here, and there seems to be several in terms of futures. Ron, this also might be a perfect one for you to address. With Project Loom, is it worth to keep reactive programming? If so, why?
Well, reactive programming is a style that emerged to allow servers to better utilize the hardware for better throughput. And I would say that it was one of the best answers to the problem of high throughput servers that you could do without changing the JDK. And in some cases, application requirements were such that that pretty much was the only choice. But despite being necessary in many situations, it clashes with the design of the Java platform. The troubleshooting information contained in exceptions, the JFR performance profiles, the debugger interface, they all assume that the context of a logical application transaction is tied to the software unit of a thread. And that assumption runs deep in the VM and tooling and even the Java language. And Reactive sort of breaks it. Again, when high throughput is required, then this might be the right price to pay. And in some cases, you have no choice. But Loom tries to solve the same problem in a way that's harmonious with the design of the Java platform and its tools. And it makes integration with legacy code easier. And it also allows programmers to use the same familiar APIs. And the reason it can do that is that it changes the Java platform itself. So my guess is that when Loom arrives, many will prefer getting better throughput with virtual threads, but those who really like the reactive style are free to keep it. And it's also possible that reactive libraries might even find ways to use virtual threads to reduce that mismatch between that programming style and the platform.
Yeah, it's just amazing the attraction that Loom has had in the ecosystem. And there's other larger projects in OpenJDK such as Panama and Valhalla and Amber that seem to get a lot of attention, as they should. But here's a closing question for all of you. With all of these very recognized projects, what are some of the next big things for consideration in Java that you think developers should become more aware of? Michael, why don't we start with you?
Oh, that is a good question. So what I actually thought about this sort of adding to the first question we covered, I think. One of the things that actually we have done, and we are much better at now than when I started working with this team 10 years ago or so, is cross-area work. We used to be set up in such a way that it was very efficient to work on the local thing, be that the JIT compiler or the language or with some part of the platform. But with all the changes we've made now, it's very seamless to work across the boundaries. So not to answer with a specific answer, but I will say that what I thrive on, what I think we do really well, and what I think we should do much more of in the future is the sort of the cross-area functionality. Making sure that when we make improvements, we think holistically through the whole platform and make sure that it's like it ties together all the way from language to libraries to VM and with the serviceability aspects on the side of it. Yeah.
Mark, as the chief architect, I'm sure you get the what's the next big thing question all the time. So how do you even wrap your hands around that type of a question?
No, I don't. I mean, we've always got ideas cooking. I think post Valhalla, Panama, and so forth. Not to steal thunder from Brian, but one thing that I'm looking forward to is type classes, which Brian has done some early work on. Maybe he wants to say a bit more. I think it would also be good to get back to some of the ideas that Ron was exploring early on in Loom, particularly around tail calls and continuations. The continuations in particular are an extremely powerful feature. It's not clear to me that we would ever want to expose them in the platform for general use, but there may be ways we could use them inside the platform in some fairly interesting ways.
That's a great comment to close on. And so for all the panelists, thank you so much for making time today to instill your knowledge on why Java still matters to all of the attendees. So thank you very much. For everyone watching, thank you for kind of ending out our day on this panel.